Hi, my name is Nick. I work with Scenic as an interconnection engineer. And today I want to take a little bit of time to talk to you about what I like to call lean disaggregated regional optical transport. That's a mouthful, but I promise that it all applies later and it all makes sense once we go through these slides. This slide just has a quick overview of what Scenic is and kind of what we do. I'm going to skip through most of these. You can look at these online. But for the gist of it is, we're a not-for-profit corporation that runs a research and education network in California that serves about 20 million end users. There's a map of the backbone with some more information about the network down below, and a kind of zoomed in map of the backbone there. You can see it goes all through California. So let's get into the meat and potatoes of this presentation here. Some background information on why we kind of went and looked at this stuff. We were looking for a crafty use of optical communication infrastructure, and that didn't necessarily have to be like a purpose-built solution that's packaged for sale. For example, like a vendor-based optical line system where you purchase everything together in like an aggregated fashion. And we had a natural application for that crafty use of the infrastructure. We were projecting that we would soon face constraints on our shorter metro segments, specifically with regard to cost efficiency and aggregate capacity available, as probably many of you have experienced. And as a bonus, by tackling the problem in this way, we can share the results of our deployment and add to the large body of NANOG presentations that cover this domain. So here's a bird's eye overview of the kind of situation we were in here. There's two sites that we have in a metro area that are connected by single mode fiber, a pair of them between the sites there, anywhere between 0 and 80 kilometers apart there. We were mainly focusing on things 3 to 12 kilometers when we were looking at what technology to use here, and the span that we ended up running on was about 8 kilometers of fiber. One site is an aggregation site where you have a large beefy router and big equipment over there, and the other site is access where you pull in peers or other networks, things like that. Basically, we need to get things from site 2 to site 1 in an efficient manner. And like with most deployments, we had a few requirements that we were up against that would shape what we were able to deploy. We wanted to deploy something that had a low overall power footprint. We could deploy like a big power guzzling behemoth gear to suit our needs for this, but power efficiency per circuit was something we were really focusing on to kind of get through this backhaul. We wanted something that was 100 gigahertz spacing compatible in order to work with the existing equipment and systems that we had in place between these sites. And we, again, wanted a reasonable cost delta compared to other solutions. One thing we weren't looking for was 100% transparent DWDM OTU transponders. For us, IP Ethernet transport was suitable between these two locations. Basically, as long as the packets got from one side to the other cleanly, we were more than happy. So let's kind of look a little bit more into this equipment here. So what did we choose to deploy? We went with 100 gigabits per second QSFP28 DWDM pluggables. They recently came to the market. They're projected to be available through many different suppliers like Adva, Arista, Juniper, Smart Optics will all be selling these type of pluggables in the future. They're generally sourced back to one manufacturer, Inphi, and that manufacturer collaborated heavily with Microsoft to refine these lean DWDM pluggables specifically for regional reach, and that's been documented in a lot of different research papers that have been presented on this topic previously. We worked with Inphi to explore that colors product for IP Ethernet transport and to demonstrate the fit within these environments that we were looking at deploying like we talked about earlier. So let's talk a little bit more about these pluggables. The first thing that we wanted to note was that while you need to take care when you're planning your deployment, like with anything, it's easy to deploy incremental channels with this technology, and you don't need expert training required to operate them. Basically, if you can operate your gear, you can pull the diagnostic information that you need to take on more complex issues and troubleshoot and escalate that way. But of course, having that centralized available expertise to escalate to remains invaluable, like it always has. These are pretty high density. You can do 32 to 36 ports per rack unit. So if you wanted to, you could fill an entire pizza box, a QSFP pizza box with these things. They're a low power draw, 4.5 watts. That's a little bit higher than you typically see with these pluggables, but it's still pretty low compared to other solutions. They got 80-kilometer reach if you have dispersion compensating fiber on there, so that hits most of your metro locations. And they, the transmitter is 2 PAM4 waves in a single 100 gigahertz channel, so that works for us with fitting in that 100 gigahertz channel that we need to work with there. They're transponder-like, so even though they're not billed as transponders, you generally use them in the same kind of situations as you would a transponder. And the FEC occurs on the pluggable, which is kind of interesting. So your host doesn't have to do anything with FEC. It's all done on the pluggable there, and they have a lower overall cost and complexity compared to some other DWDM solutions that are available. Some considerations to keep in mind when you're deploying these. They have a lower launch power, like a transmit power, than your common pluggables that you would expect in the QSFP28 form factor, like LR4 and SR4. And you also need a higher input power than your common pluggables, which basically means you need an amplifier of some sort when you're running these. Dispersion matters as well. We ran these at approximately 8 kilometers without dispersion compensating fiber, but your mileage will vary. They're also only available as a hard-coded wavelength at the moment. They're not tunable. So you have to buy kind of where, you have to think out and buy what you're planning to deploy. So let's take a look at the diagram of where we deployed these. You can see on the one side we have the router with the colors modules in it in the QSFP28 ports. In this example we ran 2 of them. We connected those into a passive DWDM 100 gigahertz spaced MUX. We dropped those through there into an amplifier, sent that across the line fiber, demuxed it on the other side, and dropped it into the optics. One thing I wanted to point out on here was the launch power specifically. You see it comes out of the optics there at neg 7 dBm per channel, like per 100 gig pluggable, sorry. So you have to be kind of intentional with your power levels when you're deploying these. As it went through the MUX, you get to neg 10 dBm per 100 gig. After the amplifier, it's at positive 10, and drop down to the optics on the other side, it's positive 3.5. So you kind of had to boost that up pretty high to get that to function across there. And the way we used these was to get those peer circuits, as I talked about earlier, back to the router on the other side. So on the deployment, it ran over those trunks there. And we put live traffic on top of this, and it ran great and passed the scream test. Nobody screamed at us that they were having problems when we put this live traffic over there, so it was a great success. And one of the main things about this is that we didn't have to have a complex prepackaged optical line system. We were able to disaggregate the components and deploy them as needed. Like for this instance, we didn't put any DCU in front, and we just used an amplifier on the one side versus having it on both sides. So we were able to deploy exactly where we needed to. So here's a view of the live traffic that we ran on there. You can see it picked up to about 50 gigs on Thursday there, across the trunks there. Here's some FEC data that we were able to pull from the optics. We have the error rate on there. The main focus on here is that we had good SNR and a good power level into the optics. So we were able to run at an uncorrected bit error rate of 0 as we went on. So what are the conclusions of our deployment that we ran through here? We were looking for a leaner option to scale our capacity or our density between our metro locations than we had previously considered or validated within our network. And these pluggables have matured enough to be suitable and cost effective for our deployment needs in many of these metro areas. They've matured enough to the point where we're happy to run that live production traffic on top of it to suit our needs. And we can continue to scale these channels fairly easily with this approach. You just add more channels and make sure your amplifiers are right as you go on. And we've also retained that flexibility for future use on the given optical segment, so we can kind of be flexible as we go forward in the future. Speaking of the future, one of the things we're going to do is further validate MACsec with the host devices. It does come for free with this pluggable. You don't have to purchase a MACsec license to run it on here. If your host can do MACsec, you can do MACsec across these links. Most of this work that occurred happened very recently. So we expect to share more details of our longer duration findings in the future. We're doing a decent amount of this work with optical communication at varying distances with varying technology. This is just one example of many things that we're doing at Scenic. We definitely welcome feedback, and we're looking for input on others that are doing similar work in this domain. We know you guys are out there. Please come talk to us if you see us, or you can reach out to us. My email's on the slide there in the slide deck. And that was basically it.
Thank you, Nick.